We are starting off this semester with Chapter 7, which I think means we've jumped around a little bit. I think the chapters go a little out of order, but here we are. Chapter 7. I will also give you a heads up that we are going to have our first quiz on Friday this week. I know, it happened fast. Just getting right back in the swing of things. But the good thing about that is that this chapter, at least the beginning of it, should be familiar to you. I believe you have all seen ratios and proportions before. I know if you took Algebra 1 here, you've seen proportions for sure. And ratios are usually something that gets introduced at a younger age anyway, so it should be review. So, our objective to use ratios and proportions. Did we all get that written down? Oh, good. All right, in our notes, a ratio is a comparison of a number A and a number B using division. So, when they say a number A and a number B, you could kind of put the A and B in quotes to help separate it out so you don't think it's like the word A. The ratio of A to B, A and B generally stand for numbers of some sort, can be written in three ways. First, as a fraction. So we would have A on top, B on bottom if it's A to B. A fraction is going to be the most common way that we will write them. But they can also be written with a colon, A dot dot B. And of course with words is how they wrote it in the beginning there, A to B. Are ratios new to anybody? Oh, good. Questions, concerns, need more time? On we go.
Can you go back?
Oh, sure.
What was the which word?
A to B, just how it's written here even.
Alright.
Anybody else? Okay. Moving on. In a ratio, the units must be the same. This is a big deal because a lot of times people will overlook this. So always check that your units are the same. You may need to convert units. We get that down. Units must be the same. Any more time before we go on to our conversion chart? Okay. A ratio must be written in simplest form. That's the other big one. Thought that was coming later. So meaning that if it's written as a fraction, we have to reduce it. That's part of the reason why we usually write them with fractions, is because that is how we are used to seeing it to be able to reduce them. Must be in simplest form. If you want to put a note there, you could even write reduce fraction. Ooh. Okay, now are we ready for our conversion chart? Yes, no, maybe so. Yes, one quiet yes. Okay. Some of these I think you'll know, like 1 foot is how many inches? 12 inches. 1 mile is how many feet? Anybody remember ballpark what it is? It is 5,280 feet. 1 meter is how many centimeters? So if we think of the prefix cent, like a century, how many years are in a century? 100. There are 100 centimeters in a meter, or there are 100 cents in a dollar. A kilometer or kilometer, depending on who you ask, is how many meters? More than 100. 1,000. A kilo is 1,000. 1 yard is how many feet? 3 feet. Certainly 3. In 3 yards, there would be 9 feet. All right, in 1 cup. Anybody know this one? 8 ounces, good. Generally, people who cook or bake would know these ones. 1 pound is how many ounces? Oh, not quite. Any other guesses? It's less than 28. There would be 16 ounces in a pound. And how many quarts are in a gallon? 4 quarts in a gallon. Now, these are not necessarily the only conversions we'll ever use. For example, you might need to know that in 1 year, there are how many months? 12, good. Okay, so we will have other conversions that are not necessarily just the ones you see here. Also things like time, like 1 hour is how many minutes? 60, right? So these are ones that I think you should be more familiar with. We don't necessarily need to write them out. Questions, concerns, need more time on this chart? All right. Then let's get into our first few examples. We'll do the first few together, and then I'll put more up and give you a minute to try them on your own. Some of our ratios here are written with colons. When you rewrite them, if you would rather write them as a fraction, that's fine by me. I don't care. Just remember, whatever number came first better go on the top of your fraction. So we could rewrite this first one as 60 centimeters over 200 centimeters. When we write ratios, we have to make sure that the what are the same. We wrote it in a note above the chart. The what? Units. Very good. We have to make sure the units are the same. So on this first example, are the units the same? Yes. Then we can go ahead and start simplifying it. So we just reduce this like a fraction, like you would any other fraction, starting in 5th grade or whenever you started doing fractions. If you need to reduce it in steps, that's fine. You don't have to go straight to your answer. For example, for me, it's easiest to see that 60 and 200 are both divisible by 10. I can just knock those zeros off, and then I have 6 centimeters to 20 centimeters. Now looking at that, do you think I'm done simplifying? No, because these can both be divided by 2. So what do I end up with? Good, 3 centimeters to 10 centimeters. Now that is simplified. My units match. I'm all done with it. If you kept it as a ratio written with colons the whole time, that's fine. Do not drop off your units. Make sure you're using your units the whole time. Questions, concerns about number 1? Okay, on to number 2. first thing we have to check is our units. Are they the same?
No.
They are not the same, which means we need to change them. Now, in this case, I think we could go either way with it, but it's always going to be easiest if we stick with making our units smaller. So meaning I want to take feet and turn it into a smaller unit of inches. So we always want to go towards the smaller unit. That'll usually make it easier if we just always follow that rule. So in this case, I am going to put my other foot, this one's in the top, so my foot is going to go in the bottom, 1 foot. And in 1 foot, there are how many inches? 12. Now, I needed my feet to be across from each other, so that way they kind of cancel out. So that way I can just keep my inches on top and on bottom. Okay, so we're always going to try to keep the smaller unit. Now, when I do this, I'm multiplying straight across the top, straight across the bottom. So in the numerator, in the top, what do I get? Good, 36 inches. And in the bottom, 18 inches. So if you want to make yourself a note near this problem that says like use or keep smaller units, that might be helpful. Now we've got our same units. We have to decide if it's simplified or if we've got more work to do. What do you think? We've got more work to do. We can simplify 36 over 18. Any ideas about what we could divide both the top and the bottom by? Yes, we can divide both top and bottom by 18. You could use a smaller number like 3 or 2 or 6, but then you'll have to take multiple steps, and that's fine like we did on the first one. But if you see it right away that those are both divisible by 18, you can go for it. What is 36 divided by 18? 2 inches. Now here is where this is a little different from just regular old fractions. You have to keep a top and a bottom, or a numerator and a denominator. So what's going in my denominator? 1 inch. So that 1 inch in the denominator has to be there. If you want to make yourself another note, ratios must have a numerator and a denominator at all times. Running out of room there. Okay, if this were a regular fraction like in Algebra 1, 2 over 1, we would write it as 2 and we would move on with our day. And in Algebra 1 and most other cases, that's fine. But with ratios, you have to have a top and a bottom. Questions, concerns about that rule? Okay, because if you go back to the definition of a ratio, it's the comparison of two numbers. I need to see both numbers. We ready to move on to number 3? On we go. First thing we check is our units. Do our units match? I see some people shaking their heads. Yes, they sure do. They're both meters. So if our units match, we can move on and just start simplifying. Any thoughts about what 35 and 700 can both be divided by? 7. Good. That's a good place to start. I'm going to rewrite it as a fraction just because that makes it easier for me. 35 divided by 7 is 5. And 700 divided by 7 is 100. So then we have to decide, is this it, or can we simplify some more? We can simplify some more because these are both divisible by 5. 5 divided by 5. 1. 100 divided by 5 is 20. Again, keep both your top and your bottom. Also keep your units. Questions, concerns, warm fuzzy feelings, cold prickly feelings, void of all emotion still. Some of us are. Bella, what's up?
So if the original question is like with a colon and then you use a fraction to figure it out and solve it, do you have to, when you answer, like your final answer, does it have to be converted back into a fraction? Or can you leave it as a...
It doesn't matter to me. You could even write it with words if you really wanted to, as long as you write it one of the 3 ways that we talked about at the top. Good question. Doesn't matter to me the format of your answer as long as it is a ratio. So fraction, colon, or with the word to, any of those would work. I default to fractions just because that's what's familiar. Are we ready for number 4? All right, first thing we check are the units. Are they the same? They are not the same. So we want to use or keep the smaller units. So what unit are we wanting to use? Anybody want to say it loud and proud? Feet. Still wasn't very loud or proud, but that's okay. I heard a few people say it. We want to use feet in this case. So I'm going to erase part of my note so I've got some space there. If I'm wanting to stick with feet, that means what unit has to go on the top? Careful. Yards, because I want them to cancel. So they have to be across from each other diagonally, one on top, one on bottom. So I'm going to put 1 yard on the top, which means what goes on the bottom? How many feet? 3 feet. Okay, I can't have both my feet on top and both my yards on bottom because then nothing's going to cancel out for me. But this way I can cancel out my bigger unit of yards and keep my units of feet. Okay? Multiply straight across the top, straight across the bottom. What do I get on the top? 12 feet. And on the bottom? 15 feet. Can we leave it there or do we need to do some more work? More work. What are those both divisible by? 3. So what do I get on top? 4 feet. Good. And in the bottom? 5 feet. That is as simple as it'll get, so I am done. Questions, concerns, or need more time with this up there before we move on? Okie dokie. Then I'll give you the last couple to try on your own. Again, write it as a fraction if you prefer. Make sure you're keeping your smaller units when you convert. And simplify your fraction. Make sure you still have a top and a bottom when you're done. On number 5, we already mentioned that we want to keep which unit? Ounces. So, what was your scale factor or conversion factor that you used? What was on top? What was on bottom? Ounces on top, pounds on bottom. What numbers went in here? How many ounces for how many pounds? 16 ounces for 1 pound. So I guess we don't really need the S on there. It could just be LB. If you left the S, that's fine. We get rid of our big unit of pounds so that we can keep our ounces. We multiply straight across the top and then straight across the bottom. So what do we get on the top?
49.
I think it should be 48 ounces, right? Over 4 ounces. Any questions about how we got to that step? We got our units to match. Then the next thing we have to do is simplify our units, or simplify our fraction, keep our units. What could we divide both top and bottom by? 4. 48 divided by 4 is 12 ounces. And what do you get in the denominator? 1 ounce. Remember, you can't just drop it off like we would with a normal fraction. We need to keep a number on top and a number on bottom. Questions on 5? All right, on number 6, we've got 2 years to 10 months. We want to keep which unit? Months. We want to keep the months because they're smaller. So we have to multiply by a conversion factor. What unit is going on top? Months, and on bottom? Years. Okay, what numbers did you use? Good. 12 months to 1 year would work. You don't need the S. If you left it, that's fine. Okay, our years go away so that we can keep our smaller unit of months. Multiply across the top, multiply across the bottom. 2 times 12? 24 months. If you want to shorten that to MO, that's fine. Over 10 months. 10 times 1 is 10. And then we have to decide, are we done or can we simplify? Simplify. Those can both be divided by 2. So we get what? Good. 12 months to 5 months. Final answer. Now, nobody brought this up, and I hope nobody was tempted to do so, but if we have an improper fraction, again, you just leave it. Don't try to change it into a mixed number or a decimal or something like that. We just leave it alone as an improper fraction or a ratio. Questions before we move on to the back and bring a little more geometry into this? Okay. In the diagram, there's not a diagram, but we'll make one. We just need a line segment. In the diagram, AB to BC is 4 to 1. So you just need a line segment. It doesn't have to be anything fancy. Labeled with an A, B, and a C. It could be a slanty line, an up and down line, a straight across line. It doesn't really matter. But a line segment, A, B, C. It says the ratio from AB to BC is 4 to 1. So I could sort of just tentatively label this with a 4 and a 1. AB with a 4 because it came first. BC with a 1 because it came second. Now, if they tell us that the length of all of A all the way down to C is 30, do you think AB really just has a length of 4? No. And BC doesn't really have a length of 1 because 4 plus 1 would not equal 30. But what we can do is say if they are in this ratio, then they must both be multiplied by the same constant in order to create this ratio. Meaning, if we were to multiply both of these by 2, for example, the ratio of 8 to 2 is the same as 4 to 1. Now, do we think the lengths are going to be 8 and 2? No, because again, they don't add up to 30. Now we could play this guess and check game and say, well, what if we multiply them both by 3? We would have 12 and 3. Is that going to work? No. So instead of playing this whole guess and check game, we could instead just assign each of these an x. We know we're going to multiply them by the same thing, so we'll call that thing x. We don't know what we're multiplying it by yet. We have questions about the logic to get me to this point. Okay, now we can go back to our first semester knowledge of segment addition. And I can add my two little pieces together and set it equal to the whole thing. So what would my equation look like? Okay, if we write it out from the beginning, 4x plus 1x equals 30, or if you go ahead and shorten it up and just tell me 5x equals 30, I'd be okay with that. I think most of you can combine 4x and 1x right away. But in case you need to see where that 5x came from, we added the two smaller pieces, set it equal to the big one. The last step to solve for x is going to be to divide by 5. You do not need to show me the divide by 5, but if you do, that's fine. X equals 6. Am I done? No, because the question told me to find A, B, and BC. So in this case, A, B. How would I find it? Good. 4 times 6. So we're plugging that x back in next to the 4. 4 times 6 is 24, which means BC is 6. Again, you could do 1 times 6 using the 1x from up here, or you could do 30 minus 24. So there we have our A, B, and BC. Questions, concerns? The tricky part of these types of ratio problems in geometry is that you have to remember to put an x in by those ratio numbers. Without that x, there's really nowhere to go except for guess and check, which is not usually super reliable. Many of you probably would have eventually gotten there to 24 and 6, but if it were a more complicated problem, then that's not going to be super helpful. Okay, so the tricky part of these is to remember that you have to put that x in there. It doesn't have to be an x. You could use a y, a z, an a, a b, whatever variable you want. Questions, concerns on 7? Moving on. The perimeter of a rectangle is 80 feet. That tells us a lot right there. The ratio of the length to the width is 7 to 3. Find the actual length and width of the rectangle. Now, diagrams are not essential, but they are useful. So we have some rectangle. The ratio of the length to width is 7 to 3. Now, based on the last problem, what do you think I want to put by the 7 and the 3?
X.
An x. We've got to remember that it's not just 7 and 3. It's 7 times something and 3 times that same thing. In order to talk about perimeter, it might be helpful to label all your sides. So what's the bottom side going to get labeled? 7x, same as the top side. And what about the left side? 3x. Remember, perimeter is what you get when you do what with all of the sides? Add them all up. So if they're talking about perimeter, I better know how to find perimeter. I would have to add all the sides together. So if I take 3x plus 7x plus 3x plus 7x again, what do I get? according to the first sentence of the problem?
180.
80. Okay, so yes, if I add them all up, all the x's up, what would I get? 20x. Do we have questions about how we got here? Okay. Then we can keep going. To solve for x, I would divide x equals, am I done? No, I actually need to find the length and the width. So the length I'll call L. How would I find the length? 7 times 4 is 28. My units? Feet. Good. The units we found from the perimeter. They snuck the units in on us. What about the width? 3 times 4 is 12 units again. Are feet. So there would be my length and my width. Again, the trickiest part about this problem, other than maybe remembering how to find perimeter, is that you've got to stick those x's in there. Questions, concerns, need more time with number 8. Okay. Let's talk a little bit about proportions. A proportion is an equation that states 2 ratios are equal. So the first ratio, A over B, or A to B, is equal to the second ratio, C over D, or C to D. In this case, B and C are called the means. A and D are called the extremes. You are going to have to be able to keep your means and extremes straight from each other. I believe there's a question on your quiz on Friday that gives you a proportion, and you have to say which letters or numbers from that proportion are the means and which ones are the extremes. Personally, I remember this best by starting with the extremes. So if I'm writing this, the first thing I write, if I were to write this out, first thing I would write is the A. The last thing I would write is a D. Generally, that's how that would go, right? A, then over B equals C, and then the last thing is D. So the extremes, the beginning and the end, that's how I remember it. A is the first thing, D is the last thing. If that helps you, great. If not, you can come up with your own way. So I remember this as first and last, or beginning and end of how I would write it. When writing. And then, of course, the other two, the means, are in the middle. Means are what you write in the middle part. However you remember this, you can decide. That's just my mnemonic for it. Questions, concerns about identifying means and extremes? Okay, continuing on. To solve a proportion, cross multiply. So what that means is the product of the means is equal to the product of the extremes. So again, the means are B and C. So B times C is equal to product, again, multiply the extremes, A times D. This should be familiar to you from Algebra 1, solving a proportion. Cross multiply means you are crossing over to the diagonal. The arrows help you. However it is you first learned how to cross multiply. Anybody need more time on this slide? Okay? So we're going to wrap up with some examples of solving proportions. In my opinion, 9 and 10 are pretty straightforward. 11 and 12, there's a small thing that we have to remember. Some people forget. Give you a minute to copy down the problems before we start talking about them. All right, on number 9, when I cross multiply, what is one of my products? What times what? I don't really care which one comes first. Okay, we could do, sorry, what? Okay, 8 times 3. I think I was hearing people say 2 different ones. 8 times 3, which when you do these, you don't necessarily need to write that out. I will this time just to show every piece of it. So we take 8 times 3 or 3 times 8, and the other product is x times 6. Remember to put an equal sign in between those products. Some people want to keep using this like it's a fraction, and that's not how it works. There is an equal sign in between them. 8 times 3 is 24. We would usually write x times 6 as 6x. If you went straight to a line that looks like this, I'm okay with that on this problem. The last thing we need to do to solve is get x alone. So we have to divide by 6. We get x equals 4. It does not matter to me if you write it as 4 equals x or x equals 4. Those are the same thing. Totally up to you. Questions about number 9? That wasn't me. So if that was you, let's make it not happen again. Number 10. What's one of my products?
3 times 45.
Okay, 3 times 45. My other product, 5 times x. Again, put an equal sign in between them. 3 times 45 is 135. And of course, 5 times x is just 5x. To solve it, we would need to divide by 5. What do we get for x? 27. So you can put 27 equals x, or you could write x equals 27. Does not make a difference to me. Questions about 9 or 10? All right, 11 and 12 are a little bit trickier. What is one of my products on 11? Okay, so I'm going to say it is 3 times y plus 2, just because I think that's going to help us on the next step. This time I used parentheses instead of a dot for multiplication. What do you think that means I'm leading you to? Distributing. You can't just multiply 3 to part of that numerator. It's got to be to the whole thing. So if you ever see part of a fraction that has more than one term in it, meaning it's not just a y, it's not just a 2, it's a y plus 2, you could go ahead and put parentheses around it. That might help you remember to multiply to the whole thing. Okay, we'll set that aside for a minute. What's my other product? 6 times 5, 5 times 6, same thing. So again, we said we put those parentheses there so that we would remember to distribute. So let's go ahead and do that. When we distribute, what do we get? Good. 3y plus 6 equals 30. This one we've got a couple steps to solve now. What's one of them? Good. Subtract 6 on both sides. We have 3y equals. Last step. Divide by 3. 24 divided by 3 is 8. So y equals 8. Or you could put 8 equals y if that's how you had it set up. There's that answer. Y equals 8. So on number 12, we have to do the same kind of thing here. So what's one of my cross products?
10 times m plus 2.
Good. 10 times m plus 2. And I'm putting that m plus 2 in parentheses so that I remember to distribute. So that I remember to distribute on my next step. What's on the other side? 5 times 14. We have to remember to distribute that 10. So what do we get
7.
when we distribute? 10m plus 20 equals the 70. Sam, you're in your seats right in front of Jakeem. Now we're ready to keep solving. Next step is to subtract. We're left with 10m equals 50. Last step. Divide by 10. M equals 5. I ran out of room, so I continued my work over there. Questions, concerns about any of these examples? Make sure you're looking out for those situations where you'll have to distribute when we've got more than one term in a numerator, or it could be in a denominator.